Alright, so continuing our discussion of parallel lines, alright, and we're going to talk about the properties that parallel lines possess. But before we can get into the properties here, we have to talk about the symbol for parallel lines when we draw figures. We already know that the longer 11 is how we say parallel on writing, but how do we say it, how do we show it with two drawings? So take your inspirational straight edge and give yourself two parallel lines. That one, let's see if I can get another one that's just like it. That's not bad. There we go. Those look almost parallel. Okay? Kind of, right? Yeah. So here's how we're going to do it. What we're going to do is when we have a drawing and we want to mark that two lines are parallel, if I call that line L and I call that line M, what we're going to do is we're going to add in an extra triangle here. See it right there? So when you see that symbol on the page, or when you need to mark that symbol on the page to represent two lines are parallel, the triangles are going to indicate to you that L is now parallel to M. If you do not see those symbols, you're not allowed to say that. So now we can say L is parallel to M because we have these symbols right here that represent parallel lines. There will be two triangles on the plane. Okay, now for what happens then? Let's say I had this, and this. And I said that these two lines were parallel. And I wanted to show that the other two lines are parallel. What would you do? Two arrows. You got it. You just anywhere on the line is totally good. So you just do two, right?
Do you have to circle?
No, you don't need to circle them. That's just me showing you which is which. That's a great question. Come on, eraser. There we go. No, you don't need to circle them.
Wait, why are the two arrows like right next to each other right there?
So this is just when I have a drawing that has two sets of parallel lines. The double arrow indicates that these two, that one and that one, are parallel, and then the single arrow indicates that these two are parallel. You got it?
Okay, but why are they?
Okay, so let's get this picture on the page. I have two parallel lines, which are the orange lines, and I'm going to indicate to you that they are parallel by drawing my little arrows in here. So. No, it doesn't matter which way they face. Okay, so now you know that the two orange lines are parallel. Is that cool with that? You guys with that part? So I'm just going to call that line L, and I'm going to call that line M. What is the green line called, ladies and gentlemen?
Transversal.
The transversal. Very good. Okay, and how many angles are created when I have a transversal? 8. I'm going to number those angles right now. I'm going to call that number 1. I'm going to call this number 2. I'm going to call this number 3 down here. So watch where I'm doing it. Number 4 over here. I'm going to call this number 5 up here. I'm going to call this number 6. I'm going to call this number 7. And that number 8. So make sure you have all the angles in the right spot. Kind of did it a little differently. It doesn't matter how we label them, just as long as they're labeled. Alright? Now, the title of this box says corresponding angles with parallel lines. Okay? So right now, I'm wondering, like corresponding angles. Angle number 1, that is the top left to line L. Do you guys agree with that? Okay, can you tell me the corresponding angle in line M? 3. The corresponding angle. So I'm going to highlight this one. This angle here and this angle here, these are corresponding, right? Ah, very good. You found something, right? If my lines L and M, if those lines are parallel, then that makes the corresponding angles what? Congruent, and that's actually a postulate. You guys just figured it out all on your own, okay? So this is a postulate. Now, a postulate can be used in what? Proofs. Very good. You guys are doing great. Postulates can be used in proofs. So, the postulate says that if, and there's no name for it, it's just a postulate. So here's the abbreviation. Okay, so if two lines are parallel, so capital P is going to be P is parallel. If parallel, okay, then corresponding, I'm going to say C-O-R-R, corresponding angles are congruent. That is the shorthand way of writing that. If P, capital P stands for parallel. So if L and M, if those are parallel lines, then we know that corresponding angles are congruent. So in this particular case, I could say angle 1 is congruent to angle what, everybody? 3. Can you give me another pair of congruent angles based on the fact that L and M are parallel. Very good. So I know that angle 2 is congruent to angle 4. And how many pairs are there total?
4.
There are 4 pairs total. Awesome. So I'll record that. So do you see that? This is what you put in the reason in the proof. So when you are dealing with a proof of this, which we're going to do, and we're going to say, if we said that, let's say for example, angle 1 is congruent to angle 3. And the reason we can say that would be right there in the blue. If 2 lines are parallel, then corresponding angles are congruent. Making sense? That would be the reason. Alright, so here's the picture we have set up for the alternate interior angles theorem. Alright, so I'm giving you a theorem now, and theorems can be used in what? In proof. So we can also use this one when it shows up. Okay, now the theorem says alternate interior angles theorem. So first of all, let's just label the interior angles, okay? I'm going to go ahead and label the interior angles. I'm going to go 1, 2, 3, and 4. Those are my interior angles. Do you agree with that?
Yeah.
Okay, good.
Does it have to be L and M?
Nope, it could be P, Q, whatever you want. I just like L and M.
Those are congruent.
Okay, now, hold on. The alternate interior. So can you give me a pair of alternate interior angles? Jake, give me a pair.
1 and 4.
Those are 1 and 4. Are those alternate interiors? No. Ashley, what do you got? 2 and 4. Good. I'm going to highlight those, okay? So this angle here and this angle here, those are alternate interior angles. What do you think, if you had to take a guess, if you had to just guess by looking at the picture, what's the relationship between angle 2 and angle 4? Do they look equal? Was one look bigger? What do you think? If you had to guess, yeah. They are congruent, yes. Okay. He's giving me the wavy sign. Yeah. So, angle 2 is indeed congruent to angle 4. What else is congruent in this case? 1 and 3. Very good. So, what we have discovered here is this, okay? So, if parallel, so if capital E parallel, okay, then alternate interior angles are congruent. Okay? If 2 lines are parallel, in this case L and M are my parallel lines. There's the whole picture right there. L and M are parallel. And we just realized that 2 and 4 are the same. So therefore, we have a theorem here. We say thank you very much for this theorem. We can use it in our proofs. If 2 lines are parallel, then alternate interior angles are congruent. And the part that's in the box right there, that's what goes where? The reason for the proof. Very good. All right. Same side interior angles. We have another theorem here. So a theorem I'm going to give you is going to be using the proofs. How do you know that R and Q are parallel? What tells you about little? Yeah, the little triangles are good. Okay, now we're talking about same side interior angles. So I'm going to go ahead. I'm going to number all the interior angles. I'm going to go 1, 2, 3, and 4. 1, 2, 3, and 4. Those are all the interior angles, right? You guys agree with that? Okay, good. Now I'm going to talk about the same side interior angles. Which one's the transversal? Which line? The green line. Okay, the green line is transversal. Okay, so which 2 angles are the same side interior angles? 2 and 4 or 1 and 3. You have 2 options here. Let's talk about 2 and 4. Okay, now there's a relationship between these 2 here. Oh, you see it right. They are supplementary. They're not congruent, right? Because they're definitely not the same angle. No way. 2 is way smaller than 4. Would you agree with that? So they're not congruent, but they do add up to a certain special number. What number is that? They're 180 degrees. So there you go. So here's what I'm going to write down for you, okay? I'm going to say this. The measure of angle 2 plus the measure of angle 4 must add up to what, ladies and gentlemen? 180 degrees. No, what you write in the thingy is this. The shorthand is this. If parallel, okay, then same side interior angles are supplementary. Okay, and what does supplementary mean? 180. So that right there in the box is how we would say it. So if our two lines are parallel, same side, interior angles are supplementary. That's the shorthand. That's what you'd write in the proof.
If you write it out, here.
Okay, let's talk about this example here. You know that the two orange lines are parallel. How do you know that? Because the two arrows indicate that they are. Good, okay. What I want you to do is I want us to be able to solve for x and to solve for y. Alright, so first thing, what type of angles are these? This one and this one. Are they alternate interior? Are they corresponding, or are they same side interior? They're corresponding. They are both top left. You guys agree with that? They are above the transversal and on the left-hand side of each line. So both top left. So these are corresponding. What do we know about corresponding angles? They are congruent. So therefore, it must be true that what?
70 equals 2x.
Must equal 2x. Very good. So therefore, if I divide by 2 and if I divide by 2, therefore x has to be 35 degrees. Okay? You guys agree with that? All right, now, if x is 35 degrees, then what must this angle be as well?
35 degrees.
No, x is 35. So this must also be 70, right? Now, if that is 70, there you go. 70 plus y equals 180. So what does y have to be?
110.
There you go. Y has to be 110 degrees. All right? Okay, here we go. We have this picture in this example. Our goal is to solve for x and y. And what do we already know about it based on the picture? Two lines are parallel. The base of the triangle, right, and then the sort of line in the middle of the triangle, those are parallel because it indicates it. All right, so let's start with the easy one. Do you guys see something? Okay. You see a lot of things. Okay, this angle here and this angle here. All right. So that actually does, even though it doesn't look like it, it is a transversal, right? Because if I extended this line and I extended that line and I extended this line, look, I have that parallel line cut by transversal. So are those alternate interior? Are those same side interior? Are those corresponding? Those are corresponding, right? And we know that corresponding angles are what? Are congruent. So therefore, x must be 50 degrees. All right? That was pretty easy. So, but are we done yet? No, we're not done yet. Okay. 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 So x is 50 degrees. Awesome. So we got that one. Now let's take a look at. Remember, these two lines are parallel. So what are those right there? Those are not corresponding. They are same side interior. They are same side interior. What do we know about? They're supplementary, right? So therefore, it must be true that y plus 68 degrees has to equal 180 degrees. So therefore, y must be 180 degrees minus 68 degrees. How much would that be? Anybody out there? 112 degrees.